Okay, for our final, it's going to be these problems that I gave you. However, you're going to notice how a couple of the answer choices are a little bit different, and one of the actual problems was incorrect as well. So the ones here are definitely correct. What we'll do is I'll show you which parts were different from the handout that I actually gave you. I'll also send you a picture of the handout with the corrections, and I'll give you the new handout tomorrow in class as well. Right here we're given the function. We're not even using calculus on this. All we're doing is just plugging in a function into another function, composite functions here. Okay. And what we'll start off with is this one first. Let's first find g of 1 because we're going to plug that into g f of x. Okay. So g of 1 gives us that right there. All I did was plug in the 1 wherever the x was, and we end up with 1/3. So now all we need to do is plug that 1/3 in to f of x. Okay, we're looking for f g of 1. Okay, we've already found g of 1, so what we're really looking for now is f of 1/3. Okay. And just plug in 1/3 everywhere you see it. X, and that gives us, actually it's negative, excuse me, get the negative. 1/3 plus 2, and we can change that to make it more recognizable how we actually multiply 2 times -1, it's -2, 1 times 3, it's 3. And I'm going to find a common denominator, which would be 3. Okay. And to get 2, it's 6/3. And finally, we have 4/3. And our answer is D. Now, remember the rule of thumb is you want to try to finish each problem in 2 minutes on average. Doesn't mean each problem is going to take 2 minutes. Some of them may take longer. Don't freak out if that happens. Some of them may not take as long. When we're finding the slope of a tangent line, we are actually looking for the derivative. Okay. And notice how we take out the square root and rename it as to the 1/2 power. So the first thing we need to do is find the slope of the tangent line, which is finding the derivative of f of x. And we'll bring that 2 over. Okay, we'll bring that 2 over, so that gives us -2x. Bring that 1/2 over. Okay, that gives us 4 times 1/2. You can also write 2 if you already see it. Go ahead and write it that way. Okay. If you already see that, that's going to equal 2. Alright, and keep in mind, right here we can do it. We got 4/1 times 1/2. That gives us 2. Okay, this reduces down to 2. And this goes into the denominator of the right portion of the problem. So we end up with -2x plus that 2 stays on top. It's not affected by the -1/2. And we got x to the 1/2. Now let's just write it as a square root, because that's how we recognize what to do algebraically. And now we found f prime everywhere of the function. Now we need to find f prime at x equals 4. What's the slope at 4 of the tangent line? So square root of 4. We got -8, 2/2, sorry, which equals -8 plus 1, -7. There's our answer. Okay, for limits, this is very important that you recognize this one is to infinity. Why, in a graph, would x do something like approach any type of infinity? That would be because of a horizontal asymptote, and that's when we use Bobo-Button E to BC. So we look at the leading coefficients. It's bigger on the bottom. Bobo. So that means that the horizontal asymptote is at 0, and that's the y value that these are approaching as x approaches infinity. Okay. This is the only kind of work I require from limits to infinity. All you need to do is write the acronym, maybe circle the coefficients if the coefficients are being used, or each DC if they're the same. Okay. Otherwise, this is all you need to show. Now, computing the derivative of trig functions, you have no choice. You have to have these memorized. Okay? There's no way around it. Okay? Just go right at it. This is probably one of the quicker problems. You got a coefficient that doesn't get touched. Derivative of secant is secant tangent. Secant of whatever is inside the parentheses. Tangent of whatever is inside the same parentheses. That's the derivative of secant. And we're going to add the derivative of cosecant. And you just have no choice. You just have to memorize it. 2. Derivative of cosecant is cosecant x, cotangent x. Negative cosecant x, cotangent x. Okay. And then right here it's just a simple algebra. Just bring that 2 up here. Multiply the negative right there. You see your answer is already given for part A. Okay, this problem was copied down incorrectly. That was my fault. Okay, first of all, if you look on your paper, this part is different. I corrected it. The exponent was incorrect. And answer choice letter C, which is a bit of a foreshadow here, was incorrect as well, which is the reason why we went insane trying to solve it. You couldn't find the answer as an answer choice. Okay, and here we need to use the quotient rule because there's a division. Okay, so we're going to do low D high, not minus high D low. Over low, low. Now from here I'm just going to distribute, okay, and I'll write the results, and if you need to pause it, go ahead and pause it so that you can do it on your own and see if it matches. If not, just follow along. And you should end up with that right there. And the next step I'm going to do is just distribute, okay, and you should end up with, before I continue, sorry, this is an 8. So distribute the negative, you end up that bad boy, okay. Now, everything cancels out nicely, as you probably already noticed. Okay, goodbye for those. These two need to be added together. Okay, these two also need to be added together, and goodbye to the 8x. Okay, after it's all said and done, you should end up with this bad boy. Of course, you can just add these two and add these two, but I decided to do it this way: combine like terms, and as far as coefficients, and then combine the rest of the like terms. And when you subtract those two, you should end up with. Whoa, and there I go again, that is not 32. 32 plus 32 is not 32. It's 64. Okay. And finishing it off, this guy right here. Now, if you look at your answer choices, it doesn't match with anything, but it's really kind of close to something like right there. If you don't see that yet, if you notice, you can factor something common in the denominator. It's just not what you might think it initially is. You might be tempted to factor out a 2x, but you have to keep the squared in consideration too. And to show that, I'm going to expand this like such. Okay. so that you can see how you factor the bottom. You have to factor each individual quantity. Okay? So we can't factor out a 2x out of this one, leaving us with 2x squared on the bottom. Okay, what is it, 2x squared? 2x to the third, so 2x to the third plus 1. And the exact same thing for the second quantity. Factor out that 2x. Remember, it's being multiplied, so maintain that multiplication property as you factor these guys out. Now you can multiply these two guys. Remember, multiplication is commutative. And then you'll end up with 4x squared. You'll end up with this. And these two are the same, so I'm going to rewrite it as itself squared, like such. And then we have x squared canceling with x4, canceling two of those x's. And then 48 divided by 4 does give you 12. And sure enough, you end up with 12x squared plus 2x cubed plus 1 squared, which is in the option. Well, excuse me, hold on. And voila, that's actually the answer choice that should have been up there. Okay. The key here is we take the derivative to find the tangent line. This one's actually asking for the normal line, which is perpendicular to the tangent line. And so find the tangent line by taking the derivative, and then use the negative reciprocal as m instead of the derivative. Okay? Use the negative reciprocal of m. And so right here we have a product, two quantities, and we're going to write that square root as a quantity raised to the 1/2. Just like that. And make sure you understand, we haven't started taking the derivative yet. Please don't write this if you're asked to show your work on an exam. Okay? That is not correct. All you're doing is renaming y so that you have gotten rid of the square root. Okay, now you use the product rule to find the derivative. And remember, once again, you have to use the chain rule for this portion. Okay, so I'll take the first times the derivative of the second. Okay, and let me color coordinate this. See, hopefully it's easier to spot what I'm taking the derivative of each time. So the derivative of the yellow would be 1/2 x squared plus 8. So it's 1/2 times the whatever's inside. Okay, the n minus 1 times the derivative of the inside, which is 2x being the derivative of the inside there. Okay. Plus the derivative of the first, which is 2 times the second. And just rewrite the second as it is. Okay. Now from here, we just got to do a little bit of algebra. Keep in mind what is in the numerator. Okay. And unlike I did the mistake in class of using this as a numerator of the whole thing. It's only the numerator of this portion of the problem. This portion does not have, sorry, denominator. It's the denominator of the left portion, not the right portion. Okay. So you'll end up with this after it's all done. Okay, I'm going to simplify and change the radicals, the exponent 1/2 exponents to radicals, resulting in this. Okay, goodbye. That reduces down to 2. All right, now we can start plugging in. It gives an x value of 0, so plug in the 0 so that you end up with that. Okay, if you need to pause it, go ahead to confirm. And then getting rid of all the zeros, this turns to 0. And here's the rest of the work. Now here's m tangent. Okay, there's m tangent. But we need m perpendicular, so it's the negative reciprocal. Okay, and that's how you write it. Now I'll finish this problem, plug it into the point slope equation. We'll do that on the next video. Okay.